Hello everybody, my name is Philip Heath from Venture Video. This is a friend of mine, Jeff Spence. Jeff has developed an improvement on the AR-15 and M16 weapon system, and it's called the Hybrid Direct Impingement System. Now, if you're familiar with the AR-15 or the M16, if you've served in the military or you have one of your own personal weapons, then you know that you spend hours cleaning these things. You also know that they're subject to failing when they get hot or after repeated use, a long time use, and get those jams and things. It's aggravating. If you're not familiar with the system, we have an animation we're going to show you how it works. Now, these weapons all use a direct impingement system, and basically the way that works is the bullet comes up into the chamber here, and then when it's fired, the bullet travels down the barrel, and the gas behind the bullet pushes it down the barrel until it reaches the port here. The gas comes up through the port and through the gas tube back through the receiver and blows that bolt to the rear, and thereby chambers another round so you're ready to fire again. Now, Jeff has made an improvement on that, and he's going to tell us about it. So, Jeff, how'd you come up with this and why?
All right, Philip. My experience with the weapon in training and in combat led me to develop this system. And due to excessive amounts of time involved in cleaning, this weapon system, which you've experienced as an enlisted man and trying to get this weapon to pass inspection, it takes a while to clean one, and jamming after sustained fire, I thought there ought to be a better way. I'm familiar with most of the weapon systems, the AK-47s, the FALs, and the different types of military weapons. They all work a little bit different than what the AR does with the direct impingement system. I've got one here. The direct impingement system uses a carrier key and uses the gas tube, which Philip just talked about. The gas travels down this tube, engages this carrier key, takes this bolt to the rear. It comes forward, chambers another round, and everything is fine as long as it functions correctly. The problem with the current system is this gas tube actually goes inside of this receiver. That's probably about right there. When this disconnects, and which it does exactly like that, inside of that upper receiver, any gas that's not used to cycle this bolt is expelled into the upper receiver. And what that causes is excessive fouling in the upper and excessive heat buildup. What I've done, with the help of a good friend of mine, Master Gunsmith Dennis Shawless, come up with a system where we extended the carrier key out and shortened this gas tube to where it is now in the lines of here and set somewhere kind of like that. So now when when you fire the weapon and the bolt goes out of battery to the rear, this disconnect happens here and the gases are vented out the upper part of the handguard. And what that does is eliminates the excessive carbon fouling and the excessive heat buildup in the upper receiver. You still have some, you never get rid of it all, no matter what the weapon system, no matter what operating system you use on your weapon, where it's gas system or a direct impingement system, or gas piston system or direct impingement system. This does solve some of the major problems with the AR-15 platform, whether you're using it to shoot coyotes or where you're using it in combat. This will help you either way. There's ultimate advantages to it. I don't have a free-floated tube, but this does make, if you free-float an AR barrel, this does make it completely free-floated, as this tube will not be connected to the upper receiver anymore, so it does give the barrel, makes it a full free-floated barrel. But overall, the major advantages to it is the heat reduction, which currently I think the military replaces these bolts about every 6,000 rounds because of this stress point, and the heat is causing that. So if we can lower the heat, my thinking was if we lower the heat, we can extend the life of these bolts and maybe save the military some money. To also maybe save us some money as consumers.
maybe save some lives from jamming while you're trying to
Exactly.
firefight.
Exactly. In a firefight, you'll see if these weapons continue malfunction. You know, that's somebody's life. That's a serious thing. I've been in combat. I know what that's like. It's not a pretty thing, and you definitely do not want your weapon to be malfunctioning in a firefight. If your weapon does malfunction with this system, the bolt remains cool enough that you can actually take it apart and hold it in your hand. So you can actually work on it if you need to. Where under the current system, if you fired 200 rounds plus, you're not going to hold the bolt in your hand because it's so hot. The cleaning afterwards, there's some changes, one other change that we've made, and that's added a cleaning port to the gas tube. I mentioned earlier we shortened it. When we shortened it, we added that gas port. This is a Bushmaster optics ready carbine upper. The only access to the gas tube, and let me hit you in the head with that, Philip. This is a gas cleaning device or pipe cleaner, but the only access to this gas tube is up through here, and you just kind of push it up through there to get it clean. It's almost impossible to do for any of you that's tried it. We did add a port here. We took out the pin in the front sight gas block area that holds it in. Now it's secured by a screw, and the hole for the screw serves as a port. So we can go in here and we can actually run this pipe cleaner all the way through that gas tube cleaning. So this better all around for the soldier in the field or for the guy that's going out target shooting every day. When he comes home, these things need to be cleaned after every time you fire them if you want them to be reliable. You may can skip a cleaning or two. Don't recommend it, especially if you're in combat, but if you do, it will last longer. We'll continue to fire.
Well, let's do a few measurements on it, and some heat measurements and some carbon fouling, and demonstrate that so you can see how it works.
We'll do some live firing, and then we'll do some heat, looking at the differences in temperatures between the regular direct impingement system and the hybrid direct impingement system. And then we'll clean them and use something most people haven't seen, but cloth diapers, and show the difference between the carbon fouling on them. And anyway, we'll go into the live fire exercise and then into the cleaning. All right. Okay, we're going to live fire the weapon. We've got 210 rounds, which was basic combat load. We'll do that with the hybrid upper and then with the standard upper. Chamber around, take the safety off, and there we go. Okay, we'll get some heat readings on this. You can tell it's hot. About 130, between 131 and 138 it varied. You can see how hot these barrels get, and that's right at the gas tube. It's varying quite a bit. It'll settle down to about 320, 300 something degrees. Handguard, upper handguard is going to be about the same temperature as the barrel. Lower handguard, quite a bit cooler. And out to the end of the barrel, still hot. On the bolt carrier, about 149, 50, 149, 150 degrees. Now we'll test the direct impingement system, the Bushmaster upper, and see what we get with it. We changed upper receivers. I've got a Bushmaster optics ready carbine with a Nikon Buckmaster scope on it. We're going to go through the same amount of rounds and then do some heat measurements on it. 210 rounds, basic combat load, and fire in the hole. She's smoking hot too. See about the same temperature there. The upper handguard a little bit cooler. Lower handguard a little bit warmer. Receiver itself 190. Yeah, getting a little erratic readings, but somewhere around 200. 203, 204. Anyway, you get the point. The bolt carrier, significant difference in heat on them. Alright, this round's complete. That magazine, we'll throw another one in. We'll take a look at the bolt. Alright, let's take a look at the bolt, Dennis, and see what kind of heat buildup we got. Looking at the bolt itself, this thing just come right out of there. It's warm, but you can see I'm still holding it in my hand. That's a basic combat load through that weapon system. And that carrier key above it is hot. It would blister my hand if I'm touching it. But you can see I'm holding this bolt. I don't have anything to measure surface temperature. I wished I did, but solves the heat issue. You can see here where the gas itself is being vented. Here in the upper receiver, locking lugs, they will have some carbon on them from the round itself as it's being ejected, but just reduces or eliminates, doesn't eliminate, but it reduces significantly the amount of carbon fouling and heat, especially the heat, which is what we're trying to accomplish in the upper receiver. Done a good job with it. The visual difference between the upper receivers, the inside of the uppers, and the difference in the carbon fouling. You'll see there is no gas tube in here, so it greatly reduces carbon fouling. Okay, all of the carbon that should have been in here went out this way. Kind of see that. You can see that. That's what an upper handguard that's used on this weapon looks like. You can see all of the carbon, and this will come off. You got to scrub it. So that would be in the upper receiver if it was not on this handguard. If you can see the gas tube with this, I'll run my finger down it. I'll have to actually clean it, but this whole upper is fouled. You know, it'll clean up. It'll be nasty. But get a good shot of that, Philip. And then the bolt. This is the bolt carrier from the Bushmaster. The hybrid direct, the direct impingement system. You'll see there's carbon fouling on the carrier key. There'll be some on the bolt, and then there's some on the key itself. Look at my hand black. touching it, and you'll see here, no carbon fouling back here on the carrier key. None. It's all kept out here. Matter of fact, there's none even on it out here. It's discolored due to heat. Now we'll break both of these down and actually clean them. And on these white diapers, it'll show up the difference with the carbon fouling. First thing I'm going to do is take just a clean one, just run it down inside of this receiver after all of that. And these were cleaned, by the way, thoroughly before we started this test. And trust me, what I'm doing right here will not pass an armorer's inspection, but you get the idea of what's actually in there. I mean, that's a pretty significant amount of carbon fouling. That's just me running my finger up in it. That's no cleaning solvents. That's just what come off. I'm just going to use the other end of this. This one, I'm doing basically the same thing. And like I said, you do get some carbon fouling with it, but as compared to the other one, that's pretty nasty. You're still going to get carbon fouling, you just don't get as much. We'll disassemble the bolts. First I'll get another one and we'll run it down just over this. And I haven't done anything to this bolt. That's it. It's all on this bolt carrier. I'm going to change sides. All I'm doing here is changing sides. You can see that it's clean. Same thing. Went from that to that. That's the difference in the fouling on it. That's just, like I said, that's just wiping a diaper on it. So significant. Sustained fire environments. This carbon builds up. You ain't got time to clean your weapon. This will make a difference. As we take them apart, not going to be a whole lot of difference in the bolt itself as far as the carbon fouling, with the exception of if there were some that escaped by it, because the Hybrid Direct Impingement System actually directs all of the gas onto the bolt and vents it out the carrier key vents or bolt carrier vents. Which you'll see, this is the Bushmaster. Just a quick wipe down of the bolt. Produce that. Then we'll go over to a clean part. Let me get this HDIS system apart. Go to the clean side here. And this should be about the same, to be perfectly honest with you, because this is where we're directing the carbon fouling to now, is where it's supposed to be. This is Gene Stoner, what he had in mind with this direct impingement system is to vent this gas through the bolt carrier. So not a whole lot of difference. Not sure which spot it was last time, but there wasn't a whole lot of difference in the two. Actually, I think it was on this one. But anyway, you get the point. Bolt carrier, significant difference as far as fouling on the bolt carrier and the carrier key. The bolt themselves, as that spent gas comes through here, it's not going to be a lot of difference internally. If you got good gas rings on your bolt, it won't get by it. So everything's held in behind that and expelled out those holes. Not so with this. As far as the barrels themselves, shouldn't be a lot of difference in fouling within the barrel, because that's a function of the gases traveling down the barrel after the round is expended. The main differences we've already discussed was the heat difference, which we've seen, and the carbon fouling in the upper receiver and on the bolt carrier itself. significantly different, and the ability to clean the gas tube on the HDIS system as opposed to the direct impingement system. It's pretty self-explanatory, but like I said, this pretty much tells it all. Where all of this, if this were left, and this stuff it's hard to get out. It takes a solvent to actually remove that. That is carbon fouling, and that would be in the upper receiver. So there's significant difference there. That's what we've reduced. We also done some heat comparisons with the AK-47. We've done it on an earlier date. I think Philip will have that on video too. You'll see it even runs a little bit hotter than than this system. So all of the AK proponents out there, you may want to look at this. Quick summary: the Hybrid Direct Impingement System just vents the gases that are currently vented in the upper receiver out the upper handguard, and it gives you an access port to clean out the gas tube, in which the current AR platform does not have. It will work with any AR lower that's out there now. This one is set up for the small hole lowers. It'll snap on to any of them. Well, I ain't got it here, but you notice I used the same lower on both weapons. Did that for a purpose, show you that this will function with any AR. So if you've got a current AR, you like it, shoots well, you don't want to change it, don't want to change it to a retrofit system to this, you can buy a complete upper and change it, just snap it onto your lower and off you go. Good system. This particular upper has over 6,000 rounds fired through it, so it's been tested thoroughly. No major malfunctions, and just a lot cleaner weapon. So I want to thank Adventure Video for doing this, and my partner Dennis Shallows, who did most of the work on it, and I hope y'all enjoyed it.